Hi guys, welcome to this video. We're going to have a look at the idea of something called the definite integral. Okay, so best way to have a look at this, I think, is to compare it to what we normally do for integration. So here is a pretty bog standard integration kind of question, and if we work through the usual process, hopefully none of you will be surprised that this should be our answer. Okay, so how does that compare with this thing called a definite integral? Well, sometimes you see integration questions where there are numbers positioned above and below the integration sign, or sometimes you might actually see them sort of parallel to the top and bottom, and then you have your function that you're integrating. So what does that mean? Well, we're still going to integrate in exactly the same usual way, but then there is a step or two extra that we need to take. Now, for now, I will leave the plus c in, but I will discuss that a bit further soon. And also, what are these weird brackets I'm putting around here? Well, the two numbers that you see positioned below and above the integral sign, just to highlight those for a moment, these are known as the limits. And yes, it is connected to the idea of limits, but I'm not going to go into that for now. Okay, so what does it mean? What do you actually have to do with these? Well, I'm just going to show you the process at the moment, and then we'll talk about the way in which there's a definition of a general definition of what should be done. Now, essentially, when you get to the stage here, we put our two limits, these limits here I'm talking about, 3 and 1 at the back here, and we simply substitute the 3 in. So we get 7, 3 to the power of 3 over 3. That's going to be 5 times 3 squared, so that's 45 over 2. So I'll just actually put the 45 plus 3 plus our constant. And then we take away what we get when we put the bottom limit in. So putting the bottom limit in will be 1 cubed, which is 1. 7 times 1 is 7, so 7 thirds. Putting the 1 in here is going to give minus 5 halves plus 1 plus our constant. Okay, so what's this going to give? Well, I'm just going to grab my calculator to help me do a bit of this. 3 to the power of 3, well, that's 27 times 7, okay, and over 3, so that's 63. I suppose I could have cancelled the 3 here. That would be 7 times 9, 63 anyway, so that would be perhaps a better way of doing it. Okay, take away for 45 divided by 2, well, that's going to be 24 and a half, not 24 and a half, 22 and a half. Sorry guys, just interrupted there a little bit, so just carrying on with this. So 45 divided by 2 would be 22 and a half. Let me just get my pen back. So 22 and a half plus 3 plus a constant. Okay, now this here will be 7 over 3, so that's 2 and a third. So it's going to be minus that, minus the negative 5 over 2, so plus 2 and a half, minus 1, minus constant, bringing the minus into each of these ones here. Right, so let's tidy this up a bit. Okay, so, well, I suppose I could mentally do that. Some of it could do, but I'm just going to grab the calculator for this. Plus 3, take away 2 and a third, plus 2 and a half. Okay, 43 and 2/3, I think. Now, one thing I would ask you to notice here, notice the constants front and back here are cancelling. Now that should not be surprising because we're going to have a plus c here and a minus our constant always. Now, I will reinforce that point when we do another example or two, but what you're going to find is that these constants will always cancel. So usually in our working, we don't bother putting the constants in. Okay, but anyway, our final answer, 43 2/3. So notice here, when we have these definite integrals with these limits here, we do get a numerical answer. Okay, so let's try and explain things in a more general sort of way. Okay, and we're simply going to go with a definition here. This is a definition of what a definite integral is. That's meant to be an n. Okay, so definition. If we have a function of x and we're deriving it, sorry, not deriving it, we're integrating it, and we've got the limits a and b here, then by definition, if we say function f of x is the integral of this function of x here, okay, then the definite integral is defined to be what you get when you put the upper limit into that integral function, take away what you get when you put the bottom limit in. Okay, and that is simply the definition of what it is. Okay, and who defined it? Well, mathematicians have defined it. Okay, that's all messy, so let me just put that word back. So this is the definition of the definite integral. So at the moment, I'd just simply ask you to treat it like an algebraic process. Okay, and don't forget that in this we're saying that f of x is equal to the integral of our function there. Okay. Alright, so let's perhaps have a look at another example then. Okay, so let's take something where we might be using a little bit of trig work maybe. Okay, so let's go with the integral, and let's go between, say, 0 and pi over 2 as our limits. And let's go with 2 sine 4x, and let's make it a little bit more complicated, minus cos x, and we're going to integrate that. Right, so let's do our integration work. Okay, so what's the integral of sine again? Yeah, that was minus cosine, I think. Okay, so if you're not too sure, if you wanted to check, what page was that on again? That was way back here somewhere. Yeah, integral of sine, definitely negative cosine, page 174 if you need to check it. Alright, so what's this going to be? Well, remember with that 4 there, we need to somehow balance the effect of the chain rule. So I think our answer is going to be negative 2 quarters cosine 4x. And let's do a little check down here. If we take this function here, let's call it negative a half, let's simplify it, cos 4x, and we derived it, okay, be negative a half, the derivative of cosine is going to be equal to negative sine, so times negative sine 4x times the derivative of what's inside, so times 4. Okay, let's tidy this up. Negative a half times negative, that's going to be positive a half. Half times 4 is 2. So 2 sine 4x. Okay, and that's what we started with here, so this is the correct integral. Okay, and we've got the integral also of minus cosine. Well, the integral of cosine is sine, so this should be minus sine plus c. And if you simplify that, of course, we'll go with that negative a half. Check the derivative of this if you like, but you will get negative cosine. Now once again I am putting the constant in, just to show you once again that when we do our working, that constant will cancel. And let's go with pi over 2 and 0, and now let's carry on, okay, now with our definite integral stuff. So we should actually have put those limits there as well. Okay, so let's substitute pi over 2 in here. So it's going to be negative a half times the cosine, or 4 times pi over 2. That to me would be 4 pi over 2, 2 pi. Minus the cosine of pi over 2 plus our constant. Alright, so all of that. Make sure when you substitute the top limit in, you put it in everywhere where there's an x. Not first time, not the first x, and you put the bottom limit into the next x. That's not the way it works. You've got to put the top limit in all the way through here. And now we're going to subtract what we get when we put the 0 in. Now be careful, don't assume that the cosine, or the trig function you're working with, so whether it's cosine or sine or tan or whatever it is, don't assume that when you put 0 in, it's going to be 0. Like for example, the cosine of 0 is not 0. But putting the 0 in, we're going to get negative a half times the cosine of 0 minus the cosine of 0 plus our constant. Right, let's tidy this up. Right, the cosine of 2 pi. Okay, time for a quick sketch. Okay, cosine function, 2 pi, there, 0 there. Cosine of 2 pi is 1. Okay, so it's going to be negative a half times 1, so minus a half. Minus the cosine of pi over 2. Well, pi is here. Pi over 2 is 0. That's pi over 2 right there. So that's going to be minus 0 plus c. And let's just carry on now. Minus, so cosine of 0, that's 1, so that's going to be minus a half. Cosine of 0, that's still 1, so minus 1, but minus 1 plus 1. Okay, and we have our plus c. So in fact, in this case, yes, the whole thing does come out to be 0. Okay, negative a half minus 0, still negative a half. Oh, don't forget sorry, that was a mistake, wasn't it? We've got minus plus c there, so let's fix that up. So our constants, I ask you to notice, are going to cancel. The 2 minus a halves will become negative 1. The plus 1 will cancel that out, and of course the minus 0 is still 0. So overall result in this case is 0. Alright, so guys, that's the basic idea of definite integrals. We're going to substitute that top limit into our integral, our antiderivative, and we're going to substitute our bottom limit into that. We're going to calculate each of those parts sort of separately, and then subtract the two results. Be careful with your arithmetic. Sometimes people like to actually just calculate what this is and then subtract the result. I've tended to go with just minus the, each part as I went. You handle the arithmetic in whichever way works for you. Okay, so there'll be a couple of questions for you to try. I'll try and keep them similar to this, and yeah, good luck with those. Make sure you're attempting the questions properly, not just guessing, and we'll see you in class next period.